Hello, everyone. Once again, here's an OpenSSF live stream. We've got someone very special today. I know I say that for every episode, but I kind of really mean it this time. Hello, everybody. My name is Ram. I'll be your host today. I'm doing a bunch of live streams on behalf of the OpenSSF, and the goal is to highlight a lot of people working in the area of security, specifically open source security. I mean, bonus points if it's about supply chain stuff. But the goal here is to sort of highlight a lot of the security work that's going on in the Indian ecosystem, so to say. We've had some amazing guests in our season so far, but we're doing this short stint in the upcoming week or so in order to highlight a particularly important event. We have the first ever OpenSSF Community Day that's happening in India. It's happening alongside KubeCon. So if you're not aware of this or if you've not had a chance to register, use this QR wherever it, I think it's here somewhere. But use the QR on the screen to, hit up the registration page and the event page. Our agenda is live. We've got an amazing lineup of speakers with some really wonderful topics that I think the developer community at large will benefit from. But also, if you're in the business of security and things like that, you should definitely be there. I think we're running a wait list right now, but we might be able to confirm a few tickets if we're lucky. So even if it's on the wait list, just get on there. Hopefully, I'll see you in Delhi on the 10th of December for the event. But today is about today. So let's bring in our special guest. Hello, Barun. Welcome to the
Hello,
show.
hey everyone.
So Barun is many things. He's a CNCF ambassador, like his jersey is showing. He's been working on a bunch of different security tooling. He works full time at Accuknox, and he's in the business of building security tools, which I think is an art unto itself. If you're building tools to secure other people's software, is there something you do to secure your own? That's going to be the big theme of today's conversation with Barun. But before we get into that rather complicated question, Barun, why don't you introduce yourself? Let's get to know you a little better.
Yep, thanks, Ram. So, like you said, I think you covered most of the things, but just about myself, I'm Barun Acharya. I'm associated with CNCF and Accuknox. I work full time at Accuknox as a software engineer, building not just KubeArmor, but an ecosystem around it to help secure software at runtime. So, as part of CNCF, I'm advocating open source security, cloud native security, helping mentoring people as part of LFX mentorship. So that's about me.
You quickly glossed through a few items. I'm going to dive in a little bit. Before we hear this whole security story, though, what is the LFX mentorship and how does one get in on it and what exactly do you contribute? Sorry to digress, but I think
No,
it'll be of value to people.
definitely, definitely. So, like in general, a quick backstory, like I got into open source because of a mentorship program called Google Summer of Code. So mentorship has played a key role in my personal career as well. So hence my inclination to keep driving any sort of mentorship programs in general. Linux Foundation has a initiative called LFX Mentorship, Linux Foundation Mentorship. It it holds it thrice a year. So there's a term one, which was earlier called Spring Session, Spring, Summer, and Fall, but it's now renamed to term one, term two, term three because seasons are not the same anymore. And basic context there is that you there are a lot of open source project in Linux Foundation ecosystem, be it Linux kernel itself. all the projects under CNCF and many more, LF networking, I'm not sure, and other aspects as well. So the maintainers of those projects come and say that these are some work items that we will help people new to open source or new to, in general, any ecosystem, help them for 3 months so that they have a particular goal in mind, and they build those projects out over the span of 3 to 6 months, depending on what's the size of their project. I guess I'll drop the links later about how one can reach out, but it's a great initiative if you are looking to dive deeper into open source in general, and uh, also helpful for projects because projects in general lack wider contributor base. So this helps projects a lot to gain new contributors, new continuous contributors. We have at KubeArmor, we have had independent contributors becoming maintainers who just started as a mentee as part of the mentorship. So it's always awesome to see that.
That's nice. Yeah, I think it's very important to educate people about available opportunities and get them to participate, and especially if it's like a good symbiotic relationship with Linux Foundation projects and any open source projects in general. Let's get into how you got started with security. How did this whole thing happen? Did you just wake up one day and decide to work on security? Or
Uh, as I said, I was getting into open source, and back then Kubernetes was just it had gained a lot of momentum. It was the second largest uh, uh, GitHub project back then, so natural inclination to try and contribute to it. While doing so, I got an opportunity to work at Accuknox. They just initially they built the baseline KubeArmor project, and most of the core functionality was there, but it was still so we knew what's the core functionality was going to be, but there were a lot of work left, and I joined Accuknox at the same time. So my initial role was just to get KubeArmor as part of CNCF. KubeArmor was part of Accuknox initially. So they decided that this being a security tool, it is important that the tool itself be vendor neutral, because opinionated security tool, like in general, vendor-based security tool, you need a lot of time to create that validation that what we are doing is what we are doing correctly. When we are part, like when a security tooling is part of a vendor neutral entity like Linux Foundation or CNCF, we realize that they run their own set of checks before they accept it under themselves, as well as helps us gain instant recognition that since it's part of an open entity, it's different, it's doing something differentiated, and whatever it is doing is actually adding value to the entire ecosystem. So that's where my work with KubeArmor started, and we are still building and expanding upon it.
amazing. Of course, we're going to get into specifics of KubeArmor in a bit, but I think the most difficult software to sell is security software. Yes or no?
Definitely, definitely. It, there are certain aspects about that we will probably dive deeper today as well. Why, like even if you sell it, there's a lot of aspects around it which needs to be controlled so that they continuously keep using it.
So, what is KubeArmor? You've mentioned it a few times. Maybe it's time to get into the details. Could you give us an overview of what exactly the tool is and how it helps folks?
Definitely. So uh, CubeArmor At a like just to say it in one line, KubeArmor is a cloud native runtime security enforcement engine. What that means is that uh, in general, when we talk about security, there are a lot of aspects. We talk about scanning for vulnerabilities. We talk about scanning for supply chain signing and verification that nothing is tampered upon. We talk about deployment aspects. But the last leg of it is runtime. Like what if when your application is actually running? Most of the attacks happen at that point of time when they're trying to exploit like unknown or new vulnerabilities or existing vulnerabilities. So all of these attacks happen at runtime. So KubeArmor is an engine to help you secure your applications at runtime. And how it does is under the hood, it uses certain kernel technologies like EVPF and Linux security modules to help you achieve that. A quick, a small example use case here would be that what if you have an application and at your run like on your runtime infrastructure someone is trying to install something. So we'll do a basic thing around what if you execute in your running application a apt install command. You don't want that. Why would you? Your containers or applications are supposed to package themselves with everything. So there's no reason for someone to run apt install on your running containers. So with KubeArmor, we can create a policy saying deny apt and apt-get in my certain container, in this case, Nginx, and it will be permission denied, and you get the entire context for further threat analysis so that you know why someone executed it or traced down the attacker there. But the fundamental point is that the attack never happened. So your application itself is secure and the vulnerability, like any loss of any data is prevented. So that's about KubeArmor. And yep, uh, there's Ram, for some reason I don't hear you.
Oh God, yes. No, I was saying, this is largely cyclic. We work with a particular technology, we learn how to secure it, and then a new paradigm comes along, and we have to relearn and rediscover a lot of the security stuff around it. And I mean, it applies to a lot of the other things like observability, also, for example. But I think it's particularly acute in the sense of security. So containers were devised for simplifying certain things, but it seemed to have introduced a new set of problems. For example, um, root level permissions on containers, and then I think there was a bit of a thing about having rootless containers, and then they said, get rid of the parts of the operating system that are not required for the application, and so package the operating system differently within the image. And so that's like the unikernels route. And so there seems to be a lot of like running around in circles, if you don't mind me using that phrase, um, especially when it comes to security. And how do you see all of that?
No, so completely valid. Just to highlight, like I do think like containers have like because the ease of use containers have provided, it's much more widely adopted, and that obviously opens up a lot of attack surface as well. But fundamentally, this problem existed on your bare metal instances as well. So, like if you have a bare metal Linux machine and you're running a monolithic application, essentially there's no segregation of entities there. And understanding what your applications are doing when all of your application exist on the same machine, it gets much more difficult. But as you pointed out, so doing like segregating individual application and scoping the attack surface of individual of them is what this is focusing towards. And there are other routes to that as well, like confidential containers, kata containers, unikernels you talked about, and fundamentally there are some other aspects like gvisor and everything. And what I think is fundamentally the differentiating factor is that all of them add a resistance to your deployment cycle. You now the, came the containers came and they simplified things. Now to just add security, you are complicating how to deploy containers and all the entities around it. That is reasonable for certain like high value workloads, but still they are adding a lot of friction to your deployment journey. And that's where KubeArmor itself differentiates itself, because this does not impact your deployment journey. It works in a plug and play manner. It independently monitors your Linux host and everything, while your actual application behavior is not impacted. So that's where we come from.
Interesting. Before we dive into the specifics, now because of the somewhat complicated nature of open source and security, and when you put the two together, somebody has a question about how we can get started on you know tools and resources. Obviously, this is a little too broad. I guess your starting point depends on what kind of open source projects you're talking about, but maybe we narrow it down to the scope of containers and Kubernetes. Mm, but let's just talk about containers. So if I'm in the business of creating and deploying containers, what's a good starting point for understanding secure development?
Valid. So like two perspectives here. So like you being an application developer is a different point, and you managing an infrastructure. Even though we talked about shift left approach, there's some like even though at the end it should be application developers packaging entirety of their software securely, there's always like operations or secops where they are also trying to secure their infrastructure itself. So on those two levels, I think that like because we are scoping it down to containers and Kubernetes, uh, the CNCF tag security has a great white paper which talks about how to approach cloud native security. They talk about various life cycles in general. Uh, 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 I don't know how can I post the link here, but uh, so essentially what they say is that there are multiple parts of your life cycle. You have your development phase, you have your distribution phase, you have deployment phase, runtime phase, access control. All these phases involve different security tools and security approaches to take. And that's you can take that white paper as a source to help you navigate navigate the ecosystem. They reference individuals. So if you open CNCF landscape, you will say 100 security tools to work around with. And usually that won't work out for you. You need to understand what kind of entities you are trying to secure. It's generally approaching any set standard. So there are multiple standards, like tag security white paper is one reference. OpenSSF has a baseline to take as a reference. Uh, NIST has a white paper which talks about what all security and like understandings you should have. CIS has a benchmark. So you can take compliances and compliance reports to understand what sort of security you need to implement, and that would narrow down your scope. of what all tools and resources to learn, and accordingly, you can implement those things up.
Yep, it's a jungle out there, to say the least. And I just posted a QR to the white paper. I'll just bring it up again. So anybody who is interested in reading that can type the word CNCF tag security white paper or scan the QR, depending on how lazy you are. Let's move on, about, talk about CubeArmor a little, and uh, the tool itself. Now, what kind of adoption does CubeArmor have, and what are its broad capabilities that have generally brought about interest in the tool?
Fundamentally, in general, KubeArmor is supposed to like provide help with inline mitigation. So you profile your application. KubeArmor provides observability. You profile your application, you understand what your application is doing. You create a least permissive or zero trust policy. So KubeArmor has a policy language which you can create policies through, and you apply it, and you are then worry free that my application will only do what it is supposed to do. Anything outside of that, I'll get an alert saying that this is not supposed to happen. Just to quickly show you on my screen, a quick zero trust policy would be something like this is Nginx, and inside my Nginx application, only user bin Nginx should be allowed to execute. Nothing outside that should be allowed to execute. So I created an allow policy saying allow Nginx. And when I try to say execute chroot now, it will be denied. And in general, anything outside execution of Nginx would be denied. But this is what is the primary USP of KubeArmor, that you can create least permissive policies and then not worry about any future supply chain attacks as well, or any future vulnerable attacks as well, because anything unknown will be prevented from executing. But this is hard to implement because you need to, Nginx being an application, it's straightforward. You have one binary running. Maybe you have a couple of files that were supposed to access, and I created, but now you have a complex Nginx configuration. It is spawning multiple chains of commands, and understanding all of that. Either you are the developer, if you are the developer, it's easy for you. But in general, if I'm just deploying or using an application, it gets difficult because I don't understand what's happening inside the application. And that's where uh, compliances come into the picture, because achieving zero trust is hard. Uh, People generally approach KubeArmor to help maintain compliance with. So adopters out there understand that. So in general, how compliance people approach compliance is that they audit or run through checks once in a while, say every day, every week, every 30 days. That's how the general approach for compliances is, whether I'm compliant to certain entities like CIS, NIST, and PCI-DSS, all those compliance frameworks. But what KubeArmor can help you add value is it can you can achieve continuous compliance. A quick example for that is, so KubeArmor has a command called KArmor recommend, so that you can get these compliance related policies. And because compliance are standardized, in general, all the policies are not application specific. You have a general set of policies which can be applied across any application. And once that's done, uh, you can just apply it and say that like I can be very free that I have been continuously compliant to these so and so checks, so that I will I'll be I'll be more secure than what I used to be. Certain I'll just take an example of like what I talked about, restricting package management execution. and this is recommended by PCI DSS compliance. So this is an out-of-the-box policy, and you can just choose to apply it. Similarly, there's NIST, MITRE, and a lot of other compliance policies. This is not just, it's not like we are not continuously updating it as well. We have a community curated list of these uh, policies, and it's ever expanding. Uh, Accordingly, we keep updating it and keep updating the recommendations so that you can achieve it. So that's the primary two audiences for like adoptions for KubeArmor. Eventually, even if you are using continuous compliances, we help like in general companies or adopters move towards least permissive because, as I said, least permissive can help you prevent attacks in the future as well about vulnerabilities that do not exist today. Compliances are based on best practices and all, and they are based on the fact that what all vulnerabilities exist today, and accordingly they are have been made. Even though because of those best practices, you can be very free for a lot of other attacks, but having a least permissive least permissive policy implemented would go a long way in your security journey.
Wonderful. So, how does KubeArmor run on a cluster?
KubeArmor fundamentally has like it has two modes of deployment. It's not limit Even though it's the name is KubeArmor, it's not limited to Kubernetes or just containers. You can run it on bare metal, anything Linux. KubeArmor can help you protect it. So be it so you as I was going to show, you have VM and bare metal deployment as well. You can keep it in cluster. Inside a cluster, it's simple Helm chart installation. And what it does is you have an operator installing daemon sets on your machine. So because KubeArmor needs node level access, it interacts with the Linux kernel. It installs itself as a daemon set, and that's where the main core engine, which provides you with the inline mitigation, runs. Uh, and outside of that, there are a lot of helper entities like the operator, the controller, relay, because it's hard. Like imagine a 100 node cluster. You yourself needing to interact with hundreds of those. KubeArmor would be nightmare for anyone managing that infrastructure. So there are a lot of tools like relay which interacts with all of these and aggregates the logs and pushes it out. We adopt the Kubernetes resource model so that you have a custom resource and management of all policies or entities of KubeArmor is through CRDs. In bare metal, they are the same YAML files. We have made sure that the same YAML configuration works over gRPC and can be shipped to KubeArmor. So that's the deployment model for KubeArmor.
Nice. I've read a little bit and heard a little bit about Falco, and I see a lot of overlap in principle and in terms of use cases and things like that. And um, are these complementary in some way? Are these similar, or is there an overlap? I'm just trying to understand and place, one tool versus the other.
Definitely, definitely. So lot of it is complementary, and there's certainly a differentiation out there. Falco is also a runtime security engine, but it's meant for observability and threat, like it's meant for alerting you with when something is supposed to happen. Uh, they have a tool called Falco Talon, which can help you mitigate as well. But the fundamental flaw is that imagine this diagram. So you have a malicious pod, and there was a malicious execution. And now Falco detected that there was a malicious execution. You have an event handler. It may be an automated event handler like Falco Talon, or a security person who received the alert that there was a malicious execution. But by the time you go ahead and kill or contain the pod, an attack was already executed. And that's fundamentally not something you want to happen. Say someone run RMRF hash test on your important data lake. So all your, even if you get to know that your application is having a malicious attack, by the time you contain it or something, it's already gone. So that's where KubeArmor differentiates. It has an inline process to, I'm not sure why this is in live mode, but yeah, so it has its own inline process so that whenever the attacker tries to execute, it's denied then and there. But then KubeArmor integrates with the Falco ecosystem to expand. So like Falco is a huge ecosystem. It's a CNCF graduated project, and obviously it's mature, and what it's doing, it's great at doing what it is supposed to do. So we leverage a lot of design decisions were inspired from Falco, and we also integrate with certain toolings like Falco Sidekick, so that you can take KubeArmor logs and have your integrations to push out. So Sidekick helps you. So these alerts are now just available in STD out or over network. Sidekick is a entity to help you publish it to Slack, message queues, AWS, any logging infrastructure you have. So those kind of integration we take from borrow from Falco and just readily integrate with that. So and because we believe, like as it told, like having in general, whatever we are building with KubeArmor, we are trying to keep it standardized. We don't want it to be too much learning curve or too much differentiated. So all the policies are CRD, all the logging is open telemetry. So anything, any inputs and outputs for KubeArmor is compatible with whatever your current infrastructure is supposed to be. So it readily integrates with most of the tooling or mature tooling out there in general.
So, in terms of that journey of finding other tools to integrate with and trying to accomplish some stuff that's slightly beyond the scope of what the tool itself does, what's the baseline in terms of user experience or usability that you approach your design with? So
Uh, like I said, l- fundamentally they came from most of them came from based on feedback or us using certain features personally. So some fundamental decisions like Kubernetes, resource model, CRDs, and having open telemetry, these were taken because that's what, like all of the infrastructure in general should be declarative, and any integration, there's a lot of mature model out there like Argo CD and Flux CD to manage these configuration files. So we don't want to say that KubeArmor will only accept security policies in gRPC. So you need to now build a model to send it over gRPC or HTTP, and those complexities, no one will like try to use it as well if we have those opinionated design decisions. So looking at the CNCF ecosystem, looking at how Kubernetes architecture works, and how Kubernetes has documented how to build controllers, operators, most of the initial design decisions came from there. But then certain other design decisions came. Uh, Suppose I was talking about how the like base approach for KubeArmor was to help you implement least permissive policies. But that's hard to do because you don't understand application behavior. Even you can do it through KubeArmor because KubeArmor provides observability as well. You can pipe it, you can keep it in certain SIM integration like Elasticsearch, create a policies out of there, but that's a lot of work. And people generally don't want to do that, at least not until they realize how important it is. So building this policy templates repo, providing out of the box compliance-based policies, having a tool so that they can, on a single command, generate these policies out there. All those came, they were iteratively made based on how users were using KubeArmor, and we realized like this adds more value and is quicker path to adoption, as well as in general eases any adopters implementation of security on their infrastructure as well. So that's how we approach in general any usability design decisions. So we get through those. Obviously, the first V1 of anything is very crude, and us as developers think that okay, this is supposed to be like that, and okay, I'm fine with it. If I can do it, someone else can do it. But then you get feedback from a lot of people and understand that no, this is hard for them. Also, even if I say that Linux, like most of the distributions out there are based on top of Linux. Even Linux has a lot of flavors out there. Kubernetes has lots of flavors out there. Uh, Managed providers have certain opinionated things. So deployment changes because KubeArmor is so closely tied to Linux. The deployment model changes and updates as well. So providing a smooth onboarding journey so that user does not need to worry that, okay, if this is EKS, I need to find where is the EKS deployment and use that. KubeArmor, we then chose to create an operator and a CLI which would automatically detect whether it's EKS, GKE, whether it's Red Hat, whether it's Ubuntu, or whatever flavor of what infrastructure you have, the installation process should be automated. So that's why now when you go to KubeArmor, it's a single Helm command or a single CLI command to install it. But in general, earlier it used to be that we had 10 deployment files present. You had to choose, you needed to realize what is supposed to be installed how. And so those kind of decisions are being made so that people are, it's quicker to adopt and it's easier for people. So people don't see security as a in their hurdle in their journey, but approach it as seamlessly as they approach any other application.
Agreed. I think that's those are all very important things to reduce the barrier to entry for these tools. And one of the other topics that comes up during a lot of discussions about these additional tools that have to run apart from the application is how much of an overhead is it? Does it introduce performance concerns? Does it introduce other security concerns? And let's deal with the security concerns you know in a bit, but let's focus on like overhead that tools like these introduce. Do you test for that? Is that like a big problem when it comes to people wanting to adopt the tool? How does that conversation go?
Definitely, definitely. And if you think when I said KubeArmor works closely with Linux kernel, you would realize that Linux kernel is doing hundreds of thousands of things every microsecond probably, and we have visibility to that information and we are trying to process it. So it's a lot of things happening. And trying and when if I just go ahead and ship it just like that, and people are saying that suddenly my resource costs are double, even if the tool itself is open source, their resource cost doubling would just make them wary of using it at all. So it's fun, like performance itself has been a crucial factor while developing the tool itself. uh, in general, this was important because security in general is seen as a cost center for organizations, right? It's not like they either they either they got attacked and now they realize that security is important, or they need to achieve like compliance due to like wherever they're operating in. So If they see it in that way, it's just a cost center for them. And even if we solve the smooth onboarding journey so that there's no friction there, if the performance itself and it's increasing the security, addition of security is increasing cost for them, they would be reluctant to use it. They would approach that, okay, maybe that tool is also providing me so and so compliance. Even if it's not the 100% correct way, it's not adding cost for me. So I'll just approach that. And we don't want that to happen. So in general, we have taken a lot of consideration. I'll just to quote that performance itself is an active item, and whatever performance benchmarking we do is out in the open source. In general, we claim that ideal case, it's less than 2% overhead. Worst case, it can be more, but we can tu tune the KubeArmor depending on your application depending on your infrastructure to reduce the overhead as much as possible. And significant development time went into achieving these numbers. For that matter, I would take an example use case. So Linux kernel has capabilities, right? So you have your application deployed with capsys admin, capsys network, or all many capabilities. And deployments generally approach. So in general, when someone is supposed to run any one privileged capability, people just deploy it with privileged equal to true instead of granularly approaching capabilities. So we built a feature in KubeArmor so that you can observe what all capabilities are supposed to be, what all capabilities are supposed to be supposed to be being used in your application. But now we realize that that's adding probably 7 or 6 or 7% of overhead to your application. We cannot have that, even though we can explain to users that if you want this, once you have done the profiling in your staging environment or in your CI/CD pipelines, you don't need it anymore. But explaining all of that is hard. So by default, these features are kept as like turned off, and when users approach it, they turn it on accordingly. Uh, so these kind of decisions, we don't want the default setting of KubeArmor to add too much over it, and accordingly, it's tuned so that when people have their first impression of KubeArmor, it's at its, I won't say it's at its peak performance, but it is at its reasonable performance so that they don't get afraid of that. Okay, I don't want to use it because
Right.
there's too much over it. So that's why performance has been a lot of work. We have spent developing tools to automate these performance so that they run in the CI. We realize that this is adding too much overhead because in general it's an ongoing process as well. You add certain feature and now you don't realize because you did not benchmark it, and it can shoot up. So because this is working at such a lower level in your infrastructure, it's also important that we don't screw up your resources so that you get afraid of implementing security in general. So that's where it is.
Got it. Now let's come to that somewhat complex question from beginning. You spoke about a ton of usability issues. You spoke about a bunch of overhead, performance profiling, and all of that. What about the security of the security tool itself? I mean, it is yet another workload. It's got to be secure. It shouldn't introduce additional vulnerabilities or you know problems into the software footprint. How do you manage to secure this particular artifact?
Definitely valid. So we approach in general KubeArmor as yet another application in your in your infrastructure. So in the grand scheme of your all the microservices that you have, we also think that KubeArmor is yet another service which is supposed to help secure things. So being a secure, being if you think a tool as an application, then all whatever you have been implementing for every other in microservice or application, you also implement it for KubeArmor as well. It's not like because KubeArmor is a system service helping you secure things, we don't get special pass to do whatever we want, and you don't need to worry about it. What we have done, we have taken a lot of steps. The first, in general, approach is that we need to understand what all KubeArmor is doing. So in on like in my screen, I can show that we went through a threat modeling exercise of KubeArmor. That okay, there's a KubeArmor pod, there's KubeArmor operator, there's a CLI, how it's interacting with the Kubernetes API, or how it's interacting with CRDs, how it's interacting with OpenTelemetry, how it's interacting with Docker, container D sockets. There are a lot of moving parts inside KubeArmor. So we need to list down all of that, all of the actors, all of the actions by those actors, and what is the supposed behavior and how can we contain it. So we went through that exercise. We've approached. I quoted CNCF tag security white paper earlier. So in general, we went through those, and whatever in general is recommended out there, we are also implementing it ourselves. Quick, uh, if I had to show security, so in general, our first, I'll start with we have a meta issue on our own, which helps us track what all entities we need to secure. And being a security engine, as I said, does not give us a special pass. So we are taking whatever approach we can to help secure things. And one of the primary things that we did was get to the OpenSSF scorecard and evaluate ourselves, where are we and what all things we need to handle. You see, some are at zero, and some are technically like we have been rated zero because it's not something we have taken approaches on our end to secure it, but the automation does not help us with, like, does not recognize that those kinds of guarding. But in general, going through this entire security OpenSSF scorecard helped us identify as well a lot of things that we were doing wrong, and it was the first step to actually achieving and helping us secure KubeArmor itself. Also, it gives a quick validation. So, like, if anyone opens KubeArmor as a if you approach KubeArmor for the first time, you see this OpenSSF scorecard right here, and accordingly, you also recognize the fact that because we are compliant with OpenSSF, you would certainly gain the trust to use KubeArmor as well. So that's why the first step we did was achieving the OpenSSF scorecard and OpenSSF best practices. Then we followed it up with other best practices, like uh, reducing whatever approaches we were taking. So just to since we talked about the Kubernetes, CNCF tag security white paper, it talks about a lot of things. You have security checks while you are in development. So these kinds of checks include vulnerability scans, your dependencies, your dependencies, further dependent, like nested dependencies are secure as well. Other things like the base images are like our container base images are not too big, and we don't ship everything in the same image, and all those considerations have been taken. Similarly, while distribution, we approach, we are all our artifacts are signed, and you can verify those signatures while admitting it so that you realize that whatever us, the developer and maintainer team or the vendor team is shipping is what you are using. Certainly, there are other aspects like while I talked about how KubeArmor can now, when we were in the process of having a smoother onboarding journey, we decided to automate detection of what kind of environment you are running in, but that requires privileges. In general, as an application, I won't know that I'm running in EKS or AKS. If our operator can recognize that, that means it has certain privileges as well. So certain design considerations around we should only detect it initially and drop those privileges ourselves so that we don't for like just in case there's a vulnerability in operator in future, even though we make sure that in the development life cycle it does not happen ever, but we make sure that at runtime or while deployment we drop those privileges out once deployed so that you are not we don't be the source of your attack as well.
Got it. Got it. Got it.
And
Has it
finally,
ever happened though? Right.
uh, not like once I'll tell a story. So it did not happen, but it was reported by a user that this could happen, and that made sense. So KubeArmor uses, as I said, Linux security modules under the hood. Just to open the reference diagram, it depends on AppArmor and PPFLSM. And when we talk about AppArmor, Kubernetes has a way to implement AppArmor profiles. It's called pod security context. And KubeArmor had the privilege to update deployments and stateful sets so that it can add the AppArmor profile to so that the process is seamless. But because now KubeArmor had that privilege, what if KubeArmor itself is now vulnerable? Anyone has supposedly, because it's now on the because now the problem is that it's fine to have that update privilege provided you are on a secure node. But having the update privilege on a daemon set is not something anyone wants because daemon sets are on all of your 100 worker nodes and you don't guarantee security on all of your 100 worker nodes. They could be on your edge machine or anywhere. So having that privilege to update across your entire node infrastructure was a huge risk. So in general, we moved that to like a different controller which is supposed to now patch these deployments, and now we can make sure that like security of that controller itself is also handled so that any worker node if compromised it does not impact your entire infrastructure as well. So those kind of, and that's something, even though like that was something that was reported to us through like our security channels, and that was taken care of accordingly. But uh, that's good, but no real attacks have happened yet, or should not happen ever, so that accordingly.
Sure. I'll probably ask you this again after we're off camera secretly. But yeah, no, I think it's a rather complex problem, and it's security in general is difficult to handle. There's a lot going on, um, and more so with building tools that are meant to help secure workloads. It would be it would be both ironic and moronic if security issues were to be introduced this way. um, we're almost at time here. So closing thoughts, Varun, anything you'd like to share that I probably missed, or some stuff about some call to action for people to get started on security in some way, or whatever it is.
No, definitely. So couple of things. Just to complete the security story, KubeArmor in general, being a security tool, it does not, or any security tool does not warrant that it should be treated differently. So KubeArmor being the same, we also try to secure KubeArmor using KubeArmor because obviously we are identifying that there's a space in your like in your development life cycle that this area is not protected. That's runtime. And even if we take all the best practices, it's still KubeArmor itself would also be vulnerable. So lot we are taking efforts to help secure KubeArmor using KubeArmor as well, so that, as I said, at the core of it, KubeArmor will be yet another application in your deployment, not a special system which has different privileges. Outside of that, for call to action, please join KubeArmor community. Help us validate. We are on CNCF Slack, so you can join us on CNCF Slack. It's hashtag KubeArmor in CNCF Slack to help ask any queries. Just give it a try, and we can discuss. There's the entire team there which can help you discuss what your infrastructure is like and how we can help you have runtime security implemented there. Uh, if you are a contributor looking to contribute to the project, KubeArmor in general has a lot of issues on GitHub. You can reach out to us. Here's the contributing.md for reference if you want to ever contribute to KubeArmor. And you don't need to just contribute code wise there because, as I said, there are a lot of aspects to KubeArmor. You can just tell us how to improve features. You can reach out to us on you can help with the policy templates, help us expand the policies and help us create policies for new vulnerabilities out there. Help us with blogs and advocating how runtime security or in general cloud native security is important. So, yep, that's all from my side.
Nice. Thanks so much for sharing links to all of those things. It was a pleasure having you today, Barun. I hope you had as much fun presenting as I did listening and learning all of these things. For those who are watching online or at a later time, our session comes to a close. But Barun, I think you're reachable on like social media somewhere or CNCF Slack and other things. Uh, so feel free to ping with questions. Um, you know just be remember to be mindful of everybody's time when you reach out. That's it from me. And yeah, if you've not had a chance to explore OpenSSF projects, do so. And just a reminder about sauce community day, if you're interested in attending, it's a free add-on to a KubeCon registration, or you can register independently. Just hit up the page. But
Quick
thanks so much
shout
for
out.
watching.
KubeArmor team will be at SOSS Community Day, so I will be there. The
Yes,
entire team will be there, so come say hi there as well.
Barun is giving a talk about
KubeArmor and how you can like lot of KubeArmor and Kiverno, how you can implement those
right
things out, but more details on the event itself.
two of the CNCF's favorite security tools at the moment, I guess. But um, I'm seeing a lot of stuff being written about and spoken about, both about Kifano and CubeArmor, of course. Thanks so much again for watching.